Who am I? Jean Valjean. Oh, additional pullback. Target streaming to zero. Let's change that. Only at Nesna.com. Not going there. You can't bait me into that. Bot! Bot! Oh, damn. What's going on with these shaders? There we go. Alrighty then. Let's go to udemy.com. Projectile movement component.
Damage, but this is a great starting point. Now let's move within fire range and see if the turrets will spawn a projectile. And of course they don't. And the reason is because we have that T subclass of variable. So if you're wondering why the turrets weren't actually spawning projectiles, you may not have set that. So let's go ahead and go into pawns and BP pawn turret and open full blueprint editor. And we placed the projectile class in the combat section. This is our T subclass of. So if we set this to BP projectile, now our turret should start spawning projectiles as well. So let's get in fire range. And there we have it. It's shooting projectiles at us, so this is looking awesome. So we now have projectiles, so let's take a look at our section plan. We've already created a tank that can move throughout the world, and we're now handling input with the WASD keys and mouse clicks. We've created an enemy turret class, we called it Tower in C++, and we've added
Hit events.
Welcome back. Now in this video, we're going to talk about hit events. We would like to detect when the projectile hits something, and that way we can do something in response, such as destroy the projectile, and later we'll handle doing damage and causing explosion effects and things like that. So let's talk a little bit about hit events. Now our projectile has a mesh component. Its type is uStaticMesh component, and uStaticMesh component is one class in a long hierarchy of classes in the Unreal Engine system. One of its parents is uPrimitive component. Here is the documentation page for uPrimitive component. It says uPrimitive components are scene components that contain or generate some sort of geometry, generally to be rendered or used as collision data. So they're basically scene components with some added features. And if you scroll down and look at the hierarchy, you'll see that we have uScene component and derived from that uPrimitive component. And you can keep scrolling down and see all of the other classes that derive from uPrimitive component. Now the reason we're pointing this out is because uStaticMesh component inherits these features from uPrimitive component, and uPrimitive component has the ability to generate hit events. Now what do we mean by generate hit events? Well, let's say we have some geometry in our world represented by the rectangle to the right, and we have an object with a static mesh component represented by the circle to the left. Now if this object that has a static mesh component is moving towards the block, then if this component is set up to handle hit events, then as soon as it hits that block, the hit event will be generated upon collision. Now, a hit event will generate some data pertaining to that collision, including the component that was hit. So this block here may have a static mesh component. We can access that component upon colliding. We can also access the actor that was hit. And the hit event also generates an F-hit result. We've learned a little bit about the F-hit result, and we know that it contains lots of variables about the hit event, such as the hit location, which is an F vector representing a location in the world. So we have our projectile mesh. This is a variable of type uStaticMeshComponent pointer. Now, whenever this static mesh component hits something in the world, we want to have some code that responds to that. Now, being a static mesh component, it inherits things from the uPrimitive component class. One of the things it inherits is a variable called onComponentHit. Now here's the documentation for onComponentHit. It's described as an event called when a component hits or is hit by something solid. Now scrolling down, we see that onComponentHit has the type fComponentHitSignature. And if we click on this, we see that fComponentHitSignature is a struct. Now, going back, we can see that the documentation says an event called when a component hits or is hit by something solid. This could happen due to things like character movement, using set location with sweep enabled, or physics simulation. For events when objects overlap, such as walking into a trigger, see the overlap event. So there are hit events and there are overlap events. We're concerned with hit events. So we know that onComponentHit is described in the documentation as a hit event. And we know that onComponentHit is a struct of type fComponentHitSignature. So far, so good. Now this hit event, onComponentHit, is also something we refer to as a multicast delegate. A multicast delegate can have multiple functions bound to it. There can be functions that exist on multiple classes, and if those functions get bound to this multicast delegate, then they're added to something called an invocation list. This is a list of functions to be called when this hit event tells them all to be called. We say that this hit event or multicast delegate broadcasts when something happens. So in the event that our projectile mesh hits something, then the delegate will broadcast to all classes that have a function bound to this delegate. As soon as that broadcast is sent, then all of these bound functions are called in response to the broadcast. This is a very powerful feature of Unreal Engine. It allows us to have this thing called a delegate, which waits for an event, such as a collision, and then the delegate will be broadcast, resulting in all bound functions called in response to the broadcast. Since multiple functions can be bound to this delegate, we call it
confusing.
Broadcast. It's broadcasting to multiple classes that have their functions bound to it. Now, how do we bind a function to this delegate? Well, onComponentHit has a number of functions that allow us to do this, one of which is called addDynamic. So when we call the addDynamic function, all we need to do is pass in two parameters, the user object, which we can use this for, and the callback function, which is the address of some function on our class. So once we access this onComponentHit delegate and call the addDynamic function, we can pass in the user object and the callback, and this will result in adding that callback to the hit event's invocation list. Now, onComponentHit will broadcast this delegate, resulting in any functions bound to it to be called. So in order to bind to this delegate, we need to create a callback function. So here's projectile.h, and we'd like a callback function for the hit event. So let's create a private function here, and it's going to be void. And I'm going to just simply call this onHit. We could call this anything we want, but onHit seems descriptive enough. Now, this callback function has to have the correct signature for hit events, which means its input parameter list needs to be very specific. The first input parameter has to be of type uPrimitiveComponentPointer, and it's called hitComp. This is the component doing the hitting. In our case, we're going to have our projectile mesh hitting things. The next parameter is an aActor pointer called otherActor. This is going to be the actor that got hit. The next input parameter is another uPrimitiveComponent pointer called otherComp. This is the other component that was hit. So if we hit the static mesh component of some other actor, then this would be that static mesh component. Next is an F vector called normalImpulse. If we're simulating physics, the physics engine will apply an impulse in response to the collision, and this F vector represents the direction and the magnitude of that impulse.
Both direction
finally,
and
we have an input
magnitude
parameter of type const, F hit result, and this is a const reference, and it's called hit. So when onHit gets called, we'll have access to a hit result that contains even more information about the hit. Now, since we're binding this to a delegate, it has to be a ufunction. So we're going to mark this with ufunction. Now, you should be familiar with ufunction. It's just like uProperty, only it's for functions rather than variables. So very important, our callback has to be a ufunction for this to work. Now, we've declared the function. Let's go ahead and define the function. So back in projectile.cpp, just under our tick function, let's define this function. We'll give it a function body and put the class name just before the function name. And now we have a callback function. So we're ready to bind this onHit function to our delegate, and we need to do this in beginPlay. Doing it in the constructor is too early, and sometimes you can run into issues like your delegate not being bound. So we're going to do it here in beginPlay. So we have our projectile mesh, and we'll use the arrow operator to access the variable inherited from uPrimitiveComponent called onComponentHit. And onComponentHit has the function addDynamic. Now, strangely, autocomplete is not going to work for addDynamic, so you're going to have to type the entire function name. This is the function we'll use to bind our callback to onComponentHit and add that function to its invocation list. Now, first we need the user object. That's going to be this, because this is the class we're binding the function for. And next we need the address to the function. That's going to be the address of onHit. So we'll use the address of operator and the function a projectile onHit. And with this, we have our function bound, and we're ready to generate hit events. Now we can test this out with a UE log. And we can use logtemp, warning, and for the text, we can simply say onHit. And if we see this in the output log, we know that our onHit function has been called. Let's compile this. So I have the output.
Chill.
We can simply say onHit. And if we see this in the output log, we know that our onHit function has been called. Let's compile this.
Oh, fuck. God damn it. Too many things to remember. People still think I'm playing Aim Labs. I'm not. Too many things to remember. I was playing Overwatch. Nobody knew. Forgot to switch my game. Alright, we are live coding as well. Build failed. Gross. Add dynamic. Okay. A, that's spelled wrong. Where is that? CPP 2833. Projectile. That's spelled right. Oh, that one. It's not a class or namespace. I mean, I'm just gonna do it again. Good heavens! Oh, and we're good. That was it. That's all I needed to do. Wait, we should up a log. Yeah, it's working.
Function name. This is the function we'll use to bind our callback to onComponent hit and add that function to its invocation list. Now, first we need the user object. That's going to be this because this is the class we're binding the function for. And next we need the address to the function. That's going to be the address of onHit. So we'll use the address of operator and the function a projectile onHit. And with this, we have our function bound and we're ready to generate hit events. Now we can test this out with a UE log and we can use logtemp. Make sure that it's working. I'd like you to explore this function a little bit more so that we can understand some of these input parameters in our onHit function. So in the onHit function, add some more UE logs. I'd like you to print the names of some of these input parameters using the getName function. I'd like you to use a UE log to print the name of hitComp, other actor, and other comp so that we could see the names of these objects we're hitting. You're going to use the %s format specifier in the UE log text macro. And just as a reminder, whenever we call getName, we have to use the asterisk when passing that string into the UE log macro. For example, to get the name of other actor, we would call other actor getName and place that asterisk at the beginning just to return that C-style string, which is what UE log expects when you format it with a string. So pause the video and use UE log in our onHit function to print the names of hitComp, other actor, and other comp.
There we go. Does this work? Probably not.
Now. Okay, so here in projectile.cpp, I'm going to use UE log here. So I'm going to copy this line where I'm using UE log, and for the string, I'm going to say hitComp, %s, and just after the text, I'm going to call hitComp getName.
Good. Goes outside of this.
And I need this asterisk to convert from an F string to a C-style string. Now I'm going to use this same line, only I'm going to change the text to say other actor, and we're calling getName this time on other actor. And finally, I'm going to print other comp, calling getName on other comp. So let's compile. And back here in the
Joe, you need to just relax. Other actor, this will be...
name on other comp. So let's compile. And back here in the editor, I'm going to go ahead and hit play and shoot a projectile. And check this out. We see that hit comp is projectile mesh. Remember, we said that this is the component doing the hitting, which is our projectile mesh. And you'll see that it's using the name that we assigned to this component in create default subobject. So this is one of those situations where that name is being used. Now, you'll see that it says other actor floor_0. And that's because the static mesh actor, that is the floor, has the name floor_0. Sometimes the engine will place a number at the end of its internal name for actors and components. And you'll see that we have that same thing happening when we print out other comp. The floor static mesh actor has a static mesh component, and its name is static mesh component 0. So this gives us a little bit more information about those input parameters in our onHit callback function. And this is useful because we have access to those objects in C++ if we'd like to do something in response to the hit event. So in summary, we have learned about hit events and how these are implemented as multicast delegates, and we learned how those work. We created a function called onHit and bound that function to the onComponentHit delegate that our projectile mesh has inherited from the uPrimitiveComponent class. Now, we haven't destroyed the projectile onHit, but we now know that we can easily do so because we have this callback function, and we can place logic in this function, such as destroying the projectile. So we'll handle that in a future video. For now, pat yourself on the back because this is one of the more complex areas of Unreal Engine C++ that you've learned so far. I'll see you in the next video.
See you in the next video. Health component.
Hey, welcome back. Now we have our projectile, and we know that it's generating hit events, so we need to do something when the projectile actually hits our target. Now that's going to involve doing damage, which means we need a way to keep track of health. So we're going to create a class for handling health and damage called a health component. And the reason this functionality gets its own class is so that we can reuse it for different classes, such as the tank and the tower. So let's discuss this health component. Now, we're familiar with the uSceneComponent class. Well, this class is derived from a class called uActorComponent. In fact, here's the uSceneComponent documentation, and in the inheritance hierarchy, you can see that its parent is uActorComponent. Now, the uActorComponent is more basic than the uSceneComponent. It has no transform, so location, rotation, and scale is not something that the uActorComponent even has. It doesn't support attachment. You can't attach an actor component to, say, a static mesh component or a capsule component. It's just something that belongs to the actor, and because there's no visual representation or transform, we don't need to attach it to anything. Compare this to the uSceneComponent, which actually does have a transform and the ability to attach itself to other components or have other components attach themselves to it. So to keep track of health and take care of damage, we don't need any of those things, so uActorComponent is going to be perfect for this. So let's hop back here into the editor and make our new actor component class. So we'll go up to Tools and New C++ class, and if I scroll down, I can see Actor Component. This is what we're going to select. Now be careful, don't select Actor. That's a different class. It's actually a bigger class and has a lot more things than the Actor Component has. We need Actor Component specifically. So select that, click Next, and this we can call simply Health Component. Let's click Create Class. Now here we have our new healthcomponent.h and .cpp files, and you can see here that uHealthComponent, the class we just created, is derived from uActorComponent. So make sure you have the correct type here, and you'll see that it has in its uClass macro this meta specifier, and it says Blueprint Spawnable Component. This is what's going to allow us to add this component directly in Blueprints, which is what we're going to do. Now the uHealthComponent is going to take care of health, which means we need a couple of variables. Let's go ahead and add these, and I'm going to make them private, so let's go ahead and add a private section just under the protected one, and we can add a couple of health variables. Now, these are going to be floats, and I'm going to call the first one max health. This will be the maximum amount of health that we can have, and we can set this to a default value such as 100.f. Now, in addition to max health, we're going to have a health value, which will be the current health, and this will be what changes as we take damage. So let's make another float and simply call this one health. Now, we can initialize health to 0.f and then set its value in begin play. And the reason we'll do that is because max health is going to have its own u property, allowing us to set it from within the details panel. So let's give this a u property and make it edit anywhere. That way we can change it as we're developing. And then in healthcomponent.cpp, here in begin play, we can simply set health equal to the value of max health. So that way, when the game starts, health will have the value of max health even after we've changed it in the details panel. Okay, so let's compile this. And back here in the editor, details panel. Okay, so let's compile this.
And in CPP, begin play. Shibloink. We didn't actually attach that to it.
And back here in the editor, I'm going to open BP Pawn Tank and open the full blueprint editor. And now I can add this health component here in the components panel.
Holy frijoles. Where did that go? I took it out? Bro, why? Just gonna close it. Successfully linked. Very good. Open, please. Did I just open like 50 of them? What's going on here, huh? Why was I able to open this? There we go.
So I'm going to click Add and search for health, and here we see health. Now, we called it health component in C++, and in fact, the pop-up shows that it's called health component. So it strips away that component part when showing it here. And you may have noticed that when you look for static mesh components or capsule components, you don't see the word component here either for those. So click on health, and now we have our health component. And you'll see that under health component, we have max health, and it's set to 100. And we don't see health because we didn't expose that variable. So now BP Pawn Tank has a health component, and it's said that the tank owns this health component. The BP Pawn Tank is the owner of this health component. Let's compile and save and close and open BP Pawn Turret and open the full blueprint editor, and we can add a health component to the pawn turret as well. So let's click Add Components, search for health, and select Health, and now we have a health component on the tower as well. So I'm going to compile and save these, close out, and save all. So we now have a health component, and we mentioned that we'd like to have a health component so that we can reuse it with different classes. So if we have a pawn in the world, say our tower, it's going to have its own health component, and then our tank can have its own health component. Now, when our projectile interacts with either one of these, for example, when it generates a hit event when hitting one of these things, then our pawns can trigger some functionality in the health component and change those health values. Putting our health functionality in a component and then adding that component to a class has some advantages over the alternative, which would be to simply place the health functionality in the base pawn class, for example, and inheriting that in the tank and tower. You see, this allows us to keep our tank and tower classes small and only deal with specified functionality for those classes, whereas the health component can be added to any other actor, such as things that don't act like tanks or towers. We can make a destructible wall, for example, which could get destroyed as soon as it takes enough damage. So let's talk a little bit about how we can make this happen. Now, Unreal Engine has built-in damage functionality, and its damage system is actually quite sophisticated. Any actor in our game inherits a number of damage events, one of which is called on-take-any-damage. This is a multicast delegate, just like on-component-hit. Now, we're going to add health components to our pawns, and these will be based on our uHealth component class. So since we know that our pawns are going to inherit this on-take-any-damage delegate, then if we create our own custom function in the health component class, then we can use this function as a callback and bind it to the on-take-any-damage delegate.
I was not
so that
paying
whenever
attention.
a damage event gets generated, the on-take-any-damage delegate can broadcast, and any functions bound to it in its invocation list will be called. So the next question is, how do we actually get that delegate to broadcast? We need a way to generate a damage event. Well, there's a function in uGameplay Statics that will do just that. It's called apply damage. If we use this static function from uGameplay Statics to apply damage takes a number of parameters, including the actor that's getting damaged. So if we call apply damage, the actor's on-take-any-damage delegate will be fired, and that callback function will be called in response. So apply damage is what generates the damage event. So to set all of this up, we have 3 steps. First, create a callback function. And since this will be bound to onTakeAnyDamage, it must have the correct input parameters so that onTakeAnyDamage will call it and pass in all of the associated information about the damage event. Step 2 is to bind this callback to the delegate. We've seen how to do this with the onComponentHit delegate using the addDynamic function. We'll be doing the same thing here. And the third step is to generate the damage event by calling the uGameplayStatics function applyDamage. So let's hop back into code and start setting this up. Okay, so we're here in health component, and we're going to add a callback function. Now this can be void, and we can call it anything we like. I'm going to call this damage taken. And because we're binding this to a delegate, it has to have the correct input parameters appropriate for that delegate. Now for functions bound to the onTakeAnyDamage delegate, the input parameter list has to be as follows. The first is an aActor pointer called damagedActor. And this is what it sounds like. It's the actor taking the damage. Next is a float called damage, and this is the actual damage amount. Now next we have a const uDamageType pointer called damageType. And the reason we have this input parameter is because Unreal Engine has the concept of damage types. You can create custom damage types that have extra data that can inform you to do different things depending on the type of damage. You may have fire damage, poison damage, explosive damage, and so on. And if you want to implement custom functionality for each damage type, then you would implement that in your own custom damage type. Now, we're not creating our own custom damage type, but because we're binding this function to the onTakeAnyDamage delegate, it has to have these input parameters. So we're including it here. Now, the next parameter is an aController pointer, and this is called instigator. In the Unreal Engine damage system, an instigator is the controller responsible for the damage. So if the damage was ultimately caused by a player controlling a pawn, then the instigator is the controller that's possessing that pawn. Now, there doesn't always need to be an instigator. If there was none, then this would simply be null. And now I'm getting the red squigglies, so I can forward declare the aController class here in the parentheses for the function. Now, the last parameter is an aActor.
What's the deal? What?
Pointer, and this one is called damage causer. This is the actual actor causing the damage. This would be the projectile itself. So we've declared this damage taken callback function, and just like our other callback function onHit, this has to be a U function. So we're going to give it the U function macro just to make sure that it works once we bind it to the onTakeAnyDamage delegate. And now that we've declared it, we're ready to define it in the .cpp file. So here in healthComponent.cpp, down at the bottom, I'm going to go ahead and give this a function body and fully qualify the function with the class name. And now we have a callback. So now we need to bind this to the delegate, but the delegate doesn't exist on the health component, it exists on actors. Specifically, we want to bind this to the onTakeAnyDamage delegate in the pawn that owns this component. So how do we access the owner of this component so we can bind to one of its delegates? Well, we would do this in begin play, and the way we can access the owner of a component is through the getOwner function. If you hover over this, you'll see that it returns an aActor pointer. This is the pointer to the actor that owns a component. Components can be owned by pawns, they can be owned by actors, so it will return the owner in the form of an actor pointer. So we have our callback function, and our second step is to bind it to the delegate onTakeAnyDamage that's going to exist on the pawn that owns the health component. So since you have experience binding callbacks to delegates, this will be your challenge. In the health component class, in begin play, you're going to bind damage taken to the onTakeAnyDamage delegate that exists on the owner of the component. So you're going to access that delegate through the getOwner function. In other words, you're going to call getOwner, and from that, you're going to access onTakeAnyDamage. And then from there, you know how to bind callbacks to delegates using addDynamic. If you get stuck, look at how we bound the onHit callback to the onComponentHit delegate. Pause the
No.
video and bind damage taken to the onTakeAnyDamage delegate now. Okay, so we're back here in health component, and we're ready to do the binding of our callback function. So here in begin play, we're going to access the owner using the getOwner function, and from there, we're going to use the arrow operator to access that delegate called onTakeAnyDamage.
Did I make onTakeAnyDamage? No. Damage taken.
And onTakeAnyDamage has the addDynamic function, and it simply takes a user object and a function name. Now the user object is the object we're binding the function for. It's the class that has the callback function on it, and that's going to be this. And finally, we have our callback function, which is going to be uHealthComponent damage taken. Now we need to remember the address of operator because this actually takes an address of the function. So now damage taken is bound to onTake any damage, and it's added to that delegate's invocation list. So whenever we generate damage events,
I don't
we will
understand
get
this.
a broadcast from this delegate, which will result in the damage taken function getting called. So in summary, we've created our very own health component, and we added one of these to both the tank blueprint and the tower blueprint. We created a callback function called damage taken, and we bound it to the onTake any damage delegate. The next step is to generate a damage event, which will result in broadcasting the onTake any damage delegate so that our callback function damage taken will get called in response. And we'll set that.
I don't get it.
Hey, welcome back. Now we've set ourselves up with a callback function bound to the delegate onTake any damage. And the last step is to actually generate that damage event. And we want to do this when our projectile hits something. Once we broadcast for this delegate, we can apply damage to the thing that we hit, and we're going to broadcast this event using applied damage, which belongs to the gameplay statics class. So let's take a look at the applied damage function. Now here's the documentation for applied damage. It says hurts the specified actor with generic damage. So this is a generic function for applying damage, and what we do in response to broadcasting for this delegate is up to us. Now here we see we need to include gameplay statics, and in the syntax we see several input parameters. Now we actually get some description of the parameters if we keep scrolling down. We see that damaged actor is, well, the actor that will be damaged. Base damage is the base damage to apply. Really descriptive documentation here. Thanks, Epic. Event instigator is the controller that was responsible for causing this damage. And it says, for instance, the player who shot the weapon. When it says player, it's referring to that controller. Then we have the damage causer, which is the actor that actually caused the damage. It says the grenade that exploded. In our case, it'll be the projectile that exploded. And finally, we have damage type class, which is a class that describes the damage that was done. Now back up in the syntax section, we can see the types of these inputs, and we see that damage type class is a T sub class of. And we've seen before that T sub class of will satisfy an input parameter of type U class. Well, when we call apply damage, we can pass in a U class representing the damage type we'd like to use. So we'll talk about how we're going to satisfy this input parameter in just a moment. So the uGameplayStatics function apply damage is going to take a few input parameters. So let's strategize on how we're going to pass in the appropriate values when we call this function. We saw that first we need the damaged actor. Well, let's go back into projectile.cpp where we'd like to call apply damage. We'd like to do it here in onHit, and we no longer need these UE logs, so I'm simply going to remove them. And notice that our onHit callback gets some inputs passed in once it gets called when the onComponent hit delegate is broadcast. We'll see that we have other actor, so we have access to the actor that got hit by the projectile. And this is the actor we would like to damage. So that takes care of the first input parameter. It's going to be that other actor. Next, we need the damage amount, which means our projectile should have a damage variable so that we know how much damage to apply. So why don't we go into projectile.h and add a damage variable? And this can be a float. So we can simply call this damage, and we can initialize it to a value. Let's say something like 50.f. And since this is something we'd probably want to experiment with, we can give this a U property to expose it and make it edit anywhere. So now we have a damage amount to pass in when we call take damage. Now the next parameter is the instigator, and we saw that this is of type a controller. So how are we going to get the controller? Well, we've seen that we can get the owner of a particular component with the getOwner function, and this returns the actor that owns a particular component. These projectiles are being spawned dynamically, so we need to make sure if we're going to be calling getOwner that the owner is set. Now we're spawning these from basepawn. So if we go into basepawn.cpp, here's the line where we're spawning the actor. But spawn actor also returns a pointer to the actor that was spawned. So we could store this in a local variable. For example, we could say auto projectile and assign the value returned from spawn actor. Now, if you're not
What is
familiar with
auto?
auto, it allows the compiler to figure out the type to assign to this new variable. If you hover over it, you'll see that it has the type a projectile pointer because that is what we're assigning from the spawn actor function. So this is the same as if we had put a projectile pointer right here. And now we can access that newly spawned projectile. And the reason we want to do that is we'd like to set its owner. We would like to make sure that it
Nah, dude. We don't want to be doing that.
owner is set to the pawn that spawned it. So we can say projectile, and there's a function for this called setOwner. SetOwner takes an actor, and we're going to pass in this so that whenever one of our pawns spawns a projectile, it will set that projectile's owner, so that way if we ever call getOwner further down the line, we'll get the instance of the class that owns that projectile. So back here in projectile.cpp, we have our getOwner function call, and we can store this in a local variable. I'm going to go ahead and use auto again and call this myOwner and set it to the result returned by getOwner. So now we have a local actor pointer that stores the value of the owner. Now we can access the instigator controller from this actor. Now before we do so, it's a good idea to check to make sure my owner isn't null. So I'm going to say if my owner is null equals null pointer, then I'm simply going to return. Now if your if body has a single statement like this, you can place it on the same line without the curly braces, in case you didn't know. And null pointer is a keyword in C++ that allows you to check to see if a pointer is a null pointer. So if my owner is null, then we will return out of the function early and not do anything else. Now, as I was saying, we can get the instigator controller from my owner, and that's with the use of the function called getInstigatorController. And if we hover over this, we'll see that it returns an A controller pointer. I'm simply going to use auto and
Yo, why are you tossing auto around, dude? Like, it doesn't make sense to me.
Local variable controller pointer. I'm simply going to use, and if we hover over this, we'll see that it returns an A controller pointer.
I'm hovering.
And if we hover over this, we'll see that it returns an A controller.
Yo.
Pointer. I'm simply going to use auto and store this in a local variable that I'll call my owner instigator. So now we know what to pass in as the instigator. The next input is the damage causer, and this is the actor doing the damage. For the projectile, this is going to simply be this, and that leaves the last input parameter, which is a damage type. And we saw that it's a T subclass of, which means we need the proper U class to pass in. Now here's the Unreal Engine documentation for U damage type. It says a damage type is intended to define and describe a particular form of damage and to provide an avenue for customizing responses to damage from various sources. Now, we're not going to customize our damage. We just need to satisfy the input parameter, which means we need a U class value that represents this U damage type class. Now, in C++, if we want to get the U class of any particular class, such as U damage type, we can call a function called static class. This is inherited from the U object class. Now, of course, we're using U damage type here, so we'll need that header. So from the documentation, I will copy the include line, and I'll paste it up here at the top of project. Projectile.cpp. And now you'll see that paste it up here at the top of projectile.cpp. And now you'll see that this static class function returns a U class pointer, and that U class will represent the U damage type C++ class. Now, since we're not creating a blueprint based on U damage type and setting some extra data, we don't really need a T subclass of variable. So in this case, we can use static class, and this will return a U class that represents this type. And we can store this in a variable if we like, and I'll call this damage type class. And this is what we can pass in as the final parameter to apply damage. So we now have all of the information we need to pass into the apply damage function. But before we do so, I'd like to place a couple of checks to make sure it's appropriate that we call this function. So I'll make an if statement here. First, I want to make sure that other actor is not null. So I'm going to place other actor here. I'm going to place an and here so I can check to make sure other actor is not equal to this actor. We don't want to cause damage to ourselves if we are the projectile. Now I'm going to place another and make sure that other actor is not equal to my owner. It wouldn't be good if the projectile is causing damage to its owner. And now, if we get inside this if statement, then we know that it's appropriate to call apply damage, so we can do so. And that's going to be your challenge. So in our new if statement, in the onHit function, call the uGameplayStatics apply damage function. This means you'll need to include the correct header for gameplay statics, and you know which input parameters to pass in. So pause the video and add the function call to apply damage in the onHit function now. Okay, so I'm here in projectile.cpp, and I'm going to include the header file for gameplay statics. And we can see from the applied damage documentation page that the include is kismet/gameplay statics. H, so I'm going to paste that in there. And now I'm ready to call apply damage. So I'm going to call you gameplay statics apply damage. Now, as soon as I type that opening parentheses, I get the pop-up reminding me of the input parameters I need. And the first one is the damaged actor, and that's going to be other actor. So we're going to type other actor. Next, we need the damage amount, and we added this damage float in projectile.h, which we set to 50. So I'm going to pass damage in. Next, we need the instigator, and we have my owner instigator. So I'm going to pass in my owner instigator. Next is the damage causer, and of course the projectile itself is the damage causer, so we're going to pass in this. And finally, we need the T subclass of for uDamage type, which we know a uClass pointer will satisfy that, and that's why we have our damage type class. So let's pass in damage type class. And with that, we're now calling apply damage. So when we call this, we will generate the damage event, and the onTakeAnyDamage delegate will broadcast in response to this, which means in our health component, damage taken will be called. So we just need to do something here in damage taken. Well, it would make sense to take this damage and subtract that amount from the health. Before we do that, though, I'd like to make sure that damage is not less than or equal to 0.f. It makes sense to make these checks before decrementing damage, just to make sure that we don't apply a value that doesn't make any sense, like 0 or a negative value. So if that's the case, we'll simply return. And of course, if you'd like to be slick and do what I did in projectile.cpp, we can place the return right there. Now, if we make it past this line, damage is a positive value, so we can take health and use minus equals damage. And just to make sure that this is working, why don't we place a UE log here? So UE log temp warning text, and we can simply print the value of health with %f and health. And with that, we can compile. Now, with a successful compile,
This is a big one. This is a big one. Health component 24. Okay, what else? Health component. I think it's just that. Ah. Projectile. Somehow always manage to do this. I think that will solve both of these. Nope. Error. Projectile undeclared. Excuse me. $43.2. Oh, base spawn. I just butchered the name of that. Got it wrong the first time. Got it right the second time, but it was actually wrong because I had named it wrong. And there we go.
We'll hop back into the editor, and with our output log open, let's hit play. Now, let's see if we can get hit by a projectile. And there we go. Our health is now down to 50. And if
Oh, shit. Wait, dock it. Can you dock? Oh wait, it is dock.
we get hit again, we got quite a few hit events because we were hitting up against the projectile many times very quickly, but we see that our health is decrementing properly. So we do need to make sure we implement the correct behavior upon death when health reaches 0, but we also need to make sure that we don't get this hit event spammed multiple times. Now, we know that the projectile should be destroyed upon hitting something, so the best way to prevent spamming the hit event is to destroy the projectile. So that's the last thing we'll do in this video. So back in projectile, just after applied damage, what we can do is have the projectile destroy itself, and that couldn't be easier. We simply call the destroy function. So with one more compile, back here in the editor, we can go ahead.
Whoa. It's just a native function.
So with one more compile,
Owie. Oh, it's 0, I'm dead. You're hurting me.
back here in the editor, we can go ahead and get hit by a projectile. And look at that, the projectile is gone. So it does its damage and then it disappears. And of course, we can test out hitting the towers as well by blasting them with projectiles and making sure that those hit events are triggering. And as you can see, I can spam this with a whole bunch of projectiles, and we'll see that the health value for this poor tower here is getting very, very negative. So in summary, we called the apply damage function, and this resulted in a broadcast for the on take any damage delegate. We decremented the health in the health component, and we destroyed the projectile. So we've now taken care of damage. We have not yet taken care of death, so that will be one of the next things we'll cover in a future video. I'll see you soon.
Death.
Hello and welcome back. In this video, we're going to talk about the game mode. We're going to use the game mode to set the default pawn class for our game, and eventually we'd like to handle death for the pawns, as well as functionality for starting and ending the game. So let's talk about the game mode class. Now, Unreal Engine has a class called a game mode. The A is there because, of course, this derives from the actor class. Now, a game mode has a parent class called a game mode base, which is a little bit more basic than a game mode. Now, in Unreal Engine, game modes are good for handling the rules of the game. This means they can handle things like the win condition for the game. Now, a game mode is a little bit more specialized and has extra functionality that we don't really need for this game project. It has a concept of match state, which is used in multiplayer matchmaking sessions, so for this reason, we're going to use a game mode base and not a game mode. Now, the process for creating a game mode class is the same as creating any other C++ class, which is why this will be your challenge for this video. Create a new class based on game mode base. We're choosing game mode base because we don't need that extra functionality in the game mode class. Now, call it Toontank's game mode or something similar, and once you've finished, create a blueprint based on this class. Now, we have a pawns folder and an actors folder. Go ahead and create a new game mode folder and place the new blueprint in the game mode folder. Go ahead and pause. pause the video and create your new game mode class now.
Yo. Hey! Clicking buttons. Oh, here it is.
Okay, so I'm back here in the editor and I'm ready to create my game mode. So I'm going to right click and select new C++ class from within the ToonTanks folder in C++ classes, and I'm going to scroll down and I see here that there's game mode base as an option. Now you'll see the pop-up says the game mode base defines the game being played. It governs the game rules, scoring, what actors are allowed to exist in this game type, and who may enter the game. So we're going to be using the game mode to determine our game rules, which will dictate when we can win or lose the game. I'm going to click next, and I'm going to call this game mode ToonTanks Game Mode, and click Create Class. Now here's my ToonTanks Game Mode. I have a .h and a .cpp, and they look pretty empty, and we're going to change that in the videos to come. But for now, we have our C++ class, and we're ready to create a blueprint based on this. So back here in the editor, I'm going to make my game mode folder here in the blueprints folder. So I'm going to make a new folder called Game Mode, and inside the Game Mode, I'm going to right click and make a new blueprint class. And here under all classes, I'm going to search for ToonTanks, and here's ToonTanks Game Mode. Clicking Select, I now have my blueprint, and I'm going to call this BP underscore ToonTanks Game Mode. So now I have a game mode. So now that we have a game mode, let's go through the steps of setting this to be our game mode for this game. And we can do that by going into Edit and Project Settings, and under Project, we see Maps and Modes. And here, under Default Modes, we see Default Game Mode, and you'll see that it's set to the Game Mode base class. We can click this dropdown and see that BP ToonTanks Game Mode is an option, and we can select that. Now, under Selected Game Mode, we can expand this dropdown, and you'll see that there are a number of properties on the Game Mode class that we can set. We can set them here, but what I'd rather do is set them in the Game Mode blueprint itself. So we can close this. There's no option to save. It's already going to save this for us. So we'll close the project settings and open up BP ToonTanks Game Mode. And here in the Details panel, under Classes, we see a number of default classes designated for the game. Now, the one I'm interested in right now is Default Pawn Class. Here we can choose the default pawn that will be possessed when we start the game. So if I click the dropdown, I can see that BP Pawn Tank is an option, and I'm going to select that. So I'm going to compile and save this and close out of it. Now we've set this tank to be possessed using the AutoPossessPlayer variable, and to remind you, I'm going to search for AutoPossessPlayer and see that it's set to player 0 for this tank. So that allowed us to possess this particular pawn without having our custom game mode set specifying the pawn class. So now that we have a game mode, we're going to remove this pawn from the world. So I'm going to hit delete and delete it. Now I'm going to zoom all the way over specifying the pawn class. So now that we have a game mode, we're going to remove this pawn from the world. So I'm going to hit delete and delete it. Now I'm going to zoom all the way over to this little thing right here and select it. you'll see that this is called a player start. You can see that here in the world outliner. Now, since we have our default pawn class set in our game mode, when the game starts, our pawn will be spawned right here at the player start. Now, if you saw this earlier in the course and maybe decided to remove it, you can always get a new player start by looking over here to the left in the place actors panel. You'll see that there are a number of classes we can drag into our world, including player start. Now, we only want a single player start. If we had multiple player starts, then Unreal Engine will be forced to choose one of them at random, but we only have a single player for this game, so we're going to use one player start. So if I go ahead and hit play, we'll see that my pawn is spawned at the location of that player start. Now, I'm moving quite slowly because we're spawning this actor based on the default blueprint, and my movement speed is set in the default blueprint to a low value. So what I'd like to do is change my movement speed. So I'm going to go into the pawns folder and open BP pawn tank and select BP pawn tank self, and here under speed, I can folder and open BP pawn tank and select BP pawn tank self, and here under speed, I can up this value to say 700. And I'm going to put the turn rate at 120. Now, if I hit play, I can move around quite a bit faster. I'm going to go ahead and save BP Pawn Tank, close out of it, and now we have our game mode set for the game. So in this video, we created the game mode class for our game, and we set this as the default game mode both in the project settings and in the world outliner to make sure that our particular level is using the correct game mode. We also set the default pawn class in the game mode blueprint, and we used a player start to spawn that default pawn rather than having a pawn already in the world and using auto possess player. In the next video, we're going to add more things to the game mode so that we can start handling gameplay logic related to the rules of the game. I'll see you in the next video.
All right, call it. Gonna rain. Well.